Welcome to My Spoiled Milk. My name is Timothy Lottis, and this is the Neo-Kino Graphics channel. Thanks for all the feedback, everyone. It's especially great to get feedback when I'm wrong. This talk is for things I got wrong or feedback-related discussions. So where's the channel growing? The answer is all over the place. I'm working on multiple talks in parallel. It's mostly a slow burn process. When one is done, I just cut the video. I have some tech talks in the pipeline, along with some random stuff. Mid-November, I'm going to choose between either just working towards finishing up a game in Vulkan or doing what my heart wants to do, which is resurrect the custom user space driver for Steam Deck and then build and release a crazy to-the-metal public domain engine. And when I say engine, I mean shader toy, effectively. And then move my game work over there. I had some random project thoughts. These are more like burnout thoughts, things that would be fun to work on that I don't have time today. Doing a new public domain scaling TAA. I think the world deserves a portable and better than ML option. And I'd like to teach people how to do that as well. Also, I found that RADV has SQTT, i.e. instruction trace support. And it would be quite awesome to have a proper trace viewer for AMD-based Steam hardware platforms. On the future video ask list, take a look at RADV disassembly. So now let's go into corrections. So it turns out the AnyBeam device, it is end of life. They don't sell it. And they never updated the website I was looking at before. However, someone did mention that AnyBeam Up is actually being sold, and it's the evolution of what I have. It also says here that it's a 3-channel device, not a 5. Thanks, John, for bringing up the point of the challenges of to-the-metal assembly versus chipset-specific hardware bugs that require in-shader workarounds. For those that are not aware, GPUs have a unique feature, which is that they don't run portable binaries. So the GPUs tend to come with hardware bugs. Some of those hardware bugs are fixed in command buffer, and some of the hardware bugs are fixed in the shader. In theory, you would see these bugs in AMD's disassembly tools on PC, but they wouldn't be highlighted. And I don't actually remember seeing them, but it might not be obvious. I think the right answer for to-metal programming is to post the errata and workaround guide, and then the dev just checks for the chipset and then does the workaround if necessary. If I continue the Steam Deck project, I'll be going in blind with no guide, and that actually doesn't scare me at all. Another viewer points out a lot of stuff on my AMD's Fine Milk talk. Specifically that my RDNA2 ISA skills are lacking. My GL extension buffer reference test was actually flawed because I used 12-bit unsigned offsets. Global ops with the flat opcode on RDNA2, it has a 12-bit offset field. However, it's signed 12-bit. It was actually RDNA3 that moved to a 13-bit one. So it happened to break in RDNA2 because I went 1 bit over. And when I switched the code to 11-bit offsets, RDNA2, 3, and 4, they're all optimized. However, it's still missing the GLC1 for coherent, so I couldn't use it. There's also a point that coherent might not be enough to disable hosting a load out of a loop. And I went back and looked this one up because I was wondering if I misinterpreted the spec. I'll quote some things from the spec. When reading a variable declared as coherent, the value returned will reflect the results of previously completed writes performed by other shader invocations. By shader invocation, they mean any invocation in the launch of the kernel. And then we have this line. When accessing memory using variables not declared as coherent, the memory accesses by a shader may be cached by the implementation to serve as future accesses to the same address. So what this says to me is take the inverse of that, that if you use coherent, that it can't cache the future accesses. And maybe that's the wrong assumption to actually just invert what they say. However, I do agree that volatile should be enough to actually fix the problem, because volatile explicitly says memory variable whose underlying value may be changed at any point during shader execution by some source other than the current shader invocation. In which case it would never be safe to hoist that out of the loop. Another comment here was not all of your issues show that AMD stops backporting optimizations to old hardware. I would actually agree with this. Things could be backported but just end up not producing the desired effect due to other side effects. For instance, in my case, my bug, having 1 bit less space of opcode. Or alternatively, AMD could be using the same compiler at quite different settings for different chipsets. We don't actually know. There was one big hint of a compiler change at RDNA3 that I didn't talk about in AMD's Find Milk, and that is during the early time of RDNA3 launch, I was seeing disassembly that didn't use the packed math ops. Now note this is despite RDNA3 having the packed math ops, same ops as RDNA2, and RDNA2 is still compiling with the packed math ops. The other interesting thing this viewer mentioned is that a compiler could have problems using both SGPR and VGPR offsets in buffer ops due to the possibility of overflow, and then perhaps having different results between the A plus B addition computed in a shader versus what happens in hardware. Likewise, the Texel buffer ops, some devs screw up the layout, and therefore they might not want to trust the byte stride computed from the layout in the compiler. So the way I see this is we have a conflict between compiler, correctness versus the needs of optimization. And perhaps this should be best solved by actually providing an extension per chipset which just exposes the hardware instructions. That way the devs can just be explicit and resolve the issues. So let's expand on this difference in priorities topic. In the vintage era, projects would be built with their own custom languages often. When the user of the language builds the language, there's a synergy between the tool maker and the tool user. There's no conflict of interest problem. Today, the compiler language and APIs are more of a gatekeeper, restricting what you can do. I find that constantly fighting a compiler takes the fun out of programming. This is why I like to build my own custom languages, whether it's for CPU or for the GPU.